Hey everybody, my name is Dallin Snell and I'm going to be talking a little bit about black box testing. So black box testing is based entirely on the requirements and specifications. So when you're looking at whatever requirement documentation you have, whether that's your SRS or some other document, all of your tests come from that. Your tests can either be functional or non-functional, and none of your tests will reference the internal structure or of the system. So you have no idea what's under the hood. You don't know what algorithms are being used. You don't know the efficiency. You're testing. Input, output, that's all. So for the steps, you're first going to examine the requirements. You have to know what you're testing, or you can just go bang your head against the wall for all the good that you're going to do. And then you determine valid and invalid inputs. Your expected outputs are then determined, and then you base your test cases on the inputs that you've chosen, execute your test cases, and then you compare the outputs that you receive versus the outputs you expected, fix any bugs or defects that you find, and then you repeat those steps until your software is perfect. Good luck on that one. Or you run out of time, you run out of budget, or you're satisfied with the way your software is working. So this is a list of 3 techniques that are normally used in black box testing. This isn't an exhaustive list, but these are the 3 most commonly used ones. Okay, so the first one is equivalence partitioning. For this one, you determine valid versus invalid data, and then you move on and you pick a sampling of data from each of those categories, and then you use that in your testing. The second one is boundary value analysis. You'll collect information on input boundaries. So for example, if you have an input buffer that goes up to 128 characters, then your boundaries would be 0 to 128. On the other hand, if you have like a budget application where your income is required to be a positive integer, then your input would be 0 to, I really don't know, I guess it would be positive infinity. And then you would enter input that is either exceeding or going below those boundaries. So for the first example, you would enter input that is 129 characters long. For the second example, since you really can't reach positive infinity, you would enter, say, a negative integer and see how the software handles that. Cause and effect graphing, for the third one, you identify your input and your output expectations. What are you going to get from what you put in? And then you create a cause and effect graph. We're going to show you an example graph a little bit later. And then you'll create your test cases based on that graph.
Hello, my name is Tyler Stanley. I'm going to be talking about the advantages and disadvantages of black box testing. But first, I wanted to go over these graphs that give a good illustration of kind of what is being accomplished by black box testing, as well as trying to illustrate what it is. So here, this first graph, it shows essentially the input is going into this black box. And the reason why it's called black box testing is because we can't see what's inside the box. The tester has no idea the technical details behind what's going on. He doesn't know how what he's testing works, but he knows what it's supposed to do. So he puts the input in, and the output comes out the other side. Now, if that output is wrong based on the functionality of whatever is being tested, then then you write up a bug and then you try to discover what is causing those issues. This next graph essentially is showing that one method of black box testing would be trying to find these cause and effects. So you'd have multiple causes all leading to the same effect. Essentially, there can be multiple causes, like you can see here, cause 1, cause 2, cause 3. They all lead to the same effect. So an example of this could be you are inputting your name into a web page, and it garbles up all the text when it should just redisplay your name on the other side. And now this happens with any word, not just your name. So you can see and narrow down the problem based on maybe the strings that are being input, so on and so forth. Now I'm going to go ahead and move to the next slide, talking about the advantages. One of the advantages of black box testing is tests are executed from the user's point of view. This is very important because this is how the user obviously will be experiencing your product. They have no idea the technical background. They don't probably have any technical background on how this is working. So they need to be able to understand fully the process that's happening. And if they're confused by the output, then it's obviously not ready to be released. And that kind of spills into the next point. Programming knowledge is irrelevant and unneeded because you don't need to know the internal mechanisms. You just need to know that there's something wrong with the input, something wrong with the output that you are putting into this black box. And what all these perspectives you're getting can be objective. They can be free of, well, this person's using a certain coding methodology or a certain language even that is known for having these issues. Without knowing any of that background, you can look at the problem as a whole rather than automatically basing it on some bias. Moving now to the disadvantage slide. One of the big disadvantages is some test cases may be left untested. Now, the reason for this is that black box testing, again, you can't necessarily see all that's happening. So you don't have all the information, and so some tests are difficult to run without that information. And then it kind of spills into the next one. Test cases can be difficult to design without robust specifications, because if you don't know exactly how the black box is working, how can you really make a test case for it? And the last disadvantage being that tests run the possibility of being redundant. So, how needed really is this test that we're running for it to be blind to the internal mechanisms? What benefit does the tester get from doing that? Some tests may have little to no benefit, but that again depends on the test parameters, and whoever is coming up with the testing paradigm hopefully wouldn't select black box testing if they would get little to no benefit from it.